So one of the things we also do, we put a fair bit of money into the Cooperative Research Centre for Spatial Information, which is where Tristan comes from. So that's a industry, business and sort of government partnership with spatial researchers, practitioners, vendors and so forth. Everyone basically in the spatial, geospatial sector. Tristan spent the past 2.5 years.
That's cool.
Is that about right?
Yeah.
Do you want to explain your PhD roughly first?
I think it'll reveal itself pretty well in what you're saying, but as I mentioned before, if people are listening, looking at using semantic techniques to connect meanings of different phrases and applying that to geospatial metadata search, so modeling both hierarchies of locations and then also the relationships between those themselves, with the aim to plug that into CKAN and use that to bring back more relevant results, which we'll see soon.
Yep. Excellent. Navigate these two. So we were at a conference for CRC-SI the past couple of days, so I've kind of taken our presentation for that lot and tried to cut it back to a non-spatial audience. So you guys kind of know the story so far in terms of open data. We've spent the past 6-7 years as a country where, various states and federal government and so forth actually collecting data, setting up teams and so forth. So I won't go into that too much. I think it's fair to say we've made some fairly decent success actually getting open data projects and programs up to the point now that we kind of have the problem that we have too much open data in our various portals. We think that's a pretty key area for Tristan's research to address. While we've collected it and catalogued it and tagged it and so forth, we kind of haven't really made use of the metadata we've captured. It's generally just displayed back to the user as just a dumb record. In some cases, you can search on tags, you can do a rough search on the there is a spatial location attached to the data set on that, but you can't really go beyond that. We don't really go beyond that in making the data any more discoverable in sort of out of the box CKAN. So it kind of feels like this. I use my portal most days, and it kind of feels like I'm using Ask Jeeves or the Vista or any of those sort of 1990s style searches. You need to know like the exact right keywords the custodian has used. My favourite example when I was trying to find a good example of this was we have a wildlife conservation data set in WA, which doesn't use the terms wildlife, flora or fauna. So you can't actually find it unless you use the exact right terms that particular custodian has gotten used. You can't do things like you can't ask basic questions that you might want to. You can't actually get insights from within the data sets itself. So it's kind of limited. It feels a bit clunky, a bit archaic, particularly when you compare it to kind of the modern experience of search. And I like to think Google's kind of ruined search for the rest of us, that users expect a search box to behave in a particular way. They expect to be able to ask questions that they expect corrections of typos and misspelled words. They expect it will bring in related terms to their search they haven't actually included. And even things like Wikidata query service or knowledge graph, where you can actually get results from within a data set or a store of knowledge itself and say, how many presidents are there, how many local governments are there, how many national parks are there, that sort of stuff. That really right now requires the user to have the expertise to go and sort of download the data set and look at it themselves. So we've done a bit of work in this space as a government community. You can increasingly find data from any particular portal, so go to the federal portal, get South Australia's data or vice versa and so on. We've kind of got a commonly agreed data standard, which is good. We're mostly collecting the same sort of information about things, but it's really still that sort of first formative stage. We think we really do have that sort of needle in a haystack problem now. You guys have got 22,000. I didn't realise the Europeans had so much on their portal. This just seems more and more sort of key, I think. So this is the point I'll get Tristan to give his demo. If you want to take the stage.
Stand to the right of the tape. Alrighty, for some reason in PowerPoint it's decided to speed everything up, so I'm going to talk very quickly. But we've got a video here of a comparison of the current Data.WA.gov and a copy of it that we've made and applied a bit of semantic sugar to. So we can see here, if we search for environment in the Pilbara on the standard instance, we get a whole bunch of 142 back. Some are relevant, some are not. If we take it in here, we only get 3 back, but we're getting a lot more relevant results. We can see something here from Port Hedland, which is a town in Western Australia in the area called the Pilbara. We also have a couple more examples here. I believe we're doing plans in Wheatbelt first, yeah. So if we type in planning here into Data.WA, again, we get 120 back. None of these really have anything to do with that particular area. It's just saying, oh, planning, okay, let me throw that. Regional parks, you know, it's not really looking at traditional planning. We put that into this one here. We can see we're actually getting plans of town sites of various towns in this particular area of Western Australia. We can then go and change the last bit to a different region of WA, for example, and then we'll just bring back only the data sets in those areas. So we can see here only getting 8 back. This one's a little bit fuzzy in that it's bringing back a couple that it shouldn't, but it is still providing much better than the one here, and that's simply because, despite not being in the area Great Southern, that one's showing up in both because there's a company called Great Southern Railway who ran through it. So the idea is that we've modelled a few different relationships in RDF format. So the difference pretty much saying, you know, this area has these towns in it. You know, we have a concept, for example, of planning, and we have 4 or 5 different ways to represent it. And then the way it's implemented is as a Python script connected to another system, which probably won't go into, as it'll take a long time to describe it, but effectively we're pulling out the relevant bits of that query. We're taking it from CKAN, piping it into this, taking out the important bits, running a query, bringing everything back, and then searching for everything in summary. Back to you. Oh, they're straight here. Okay. I'll continue on. Okay. So I thought I'll briefly go through some slides describing the theory of it that I've presented before. I work with a bunch of other students on Program 3 of the CRC for Spatial Information. We're all solving similar problems. So this one here is a slide I made with a set of slides rather I made with another student who is looking to solve similar problems in a similar sort of way. So the problem is, especially using any sort of web tool, be it if it's just pulling back data sets itself or even a WebGIS system like this, it's making things so much easier, but then it just means more and more of your time, percentage-wise, is being wasted actually finding the data you're looking for. You know, that might be even if it is in a CKAN instance itself, or unfortunately if it's not, then that's even more difficult because there's not an easy way to get it. We need to know who to talk to, where to visit. Luckily, thanks to these wonderful open data portals, that's all becoming condensed into one place to make it easier for us. And quite often when we do find the data we're looking for, there's a whole bunch of very similar data with very similar metadata. You know, maybe it's different versions and it's not quite stored in a very easy to understand way. Perhaps it's only stored as an internal ID. Perhaps it's, you know, various representations of the same thing with, again, unusual descriptions of it. So it's a lot of work on the user to actually sift through all of this and try and work out what exactly they need. And of course, if we're using a traditional keyword-based search, we end up with the problem that unless I say exactly what you were thinking, we're not going to find anything. And of course, if we have lots of very similar but very, very slightly different data sets, it's going to be very, very difficult to hit the one we're looking for. So there's an example here of the CKAN instance in the field of health, so that's what the other PhD student, she's looking into. So for example here, if we search for type 2, it's searching for 2 and type. So we're getting SA2 based land tenure type, nothing to do with type 2 diabetes, which is what most people would probably think when we say type 2. Of course, if you type in just mellitus, which is another way to say diabetes, nothing's coming in. And of course, if you're saying diabetes itself, we would get some stuff back. Context is another issue. So it's quite often that you'll type something in and it could have many different meanings. K12 is a great one because it's a disease code in health, but it's also an abbreviation for schooling type and also a mountain in West Asia. So it's quite easy to pull things out of the search, but then there's the next step of saying, okay, I've got something here, but which one did I mean? So the context of what you're actually looking for, which is obviously dependent on what's around the thing itself in your search query, for example, in this case, can have quite a big difference. So for example, if we look at Perth in the query, if we go looking at either the SA3s and SA4s or the suburbs SA2s, just in the Perth metropolitan area, we've got Perth, West Perth, Perth Airport. And I'd say it's the same in most cities, that there's often west this city, east this city, north this city airport as suburbs. And of course, which one were we referring to? Were we referring to the smaller suburb in the SA2 of Perth? We're referring to the larger one in the SA3, SA4, or perhaps the even larger still regions of Perth. The idea is you could even be confused for Perth in Tasmania, which is a sort of two-street town. Quite a nice place, but not what you might be looking for if you're trying to find data about Western Australia. So the idea is that without understanding the context of what you're looking for, it's very hard to break it down. So taking a look at an example query where we're breaking down sort of the query into its constituents, then applying the semantic sugar to it. There's questions that need to be asked about each bit. So, for example, if we're just doing a traditional search of environment in Tom Price, which is a place in Western Australia, environment, if you don't say environment, you say climate and habitat instead. That's why we need to look up and see, okay, what words are related to these? Simply because if you say that and I say this, we're not going to meet in the middle. Of course, what's the relationship between what we're looking for and the location we want to describe? We're only wanting to pull back data about a particular location. We want to know, well, is the data set wholly within that? Is the area wholly within the data set? It's probably going into the spatial side of things a bit too much there, so we won't go much further in that bit. Also mindful of time. And Tom Price, we get back to that issue of which thing, where is it? So to achieve the mapping, we're using what's called an ontology, which if you're not familiar is just a representation of linked data. So we're showing various different things, attributes about either real world things or even, intangible things, and then how they relate to each other. So it's really taking sort of a relational view of the world, but then also determining, well, what do these things, what's the meaning between the relationship between different attributes as well. Now, of course, we can always just use traditional metadata, but there's quite often issues there. A lot of the time it's not sufficient, as we unfortunately know. There's a lot of overhead in creating it. Sometimes metadata can automatically be created depending on what the data source itself is. It might have inherent properties that we can use. Otherwise, we might need to run tools over it to get these things, because without either effective metadata or taking the approach of trying different things, so to speak, by looking at similar words, it's very hard to bring back what you need. So we've got an example here of, I think that was off Data.WA, and 2/3 of that's a bit too small here. 2/3 of that is just boilerplate text about Landgate, the West Australian Land Information Authority. I might skip through this part as it's not too relevant, sort of going into the technical details of some other stuff. and hand it back to
Cool. Keith. So this is very proof of concept right now. I first saw the working one yesterday morning. So we'll be spending the next probably 6-9 months looking at an alpha version of this, a beta version, actually getting feedback from ourselves internally and more of our users. But it is being developed as a CKAN extension. So ultimately, we would love this to be able to plug into any of your other portals and have a bit of a think about how that works with federated search, at least within Australia as well. So that's where we're going, better search.
yeah.
So